Welcome to the deep dive. We've got this really substantial study guide you sent over on Windows Server 2022 hybrid administration.
Yeah, it's pretty comprehensive.
So our goal today, basically, is to pull out the core stuff you really need to know.
Right.
Think virtualization, networking, bridging on-prem, and Azure identity, storage, security, and disaster recovery. We want to hit the key points without getting totally lost in the details.
Exactly. And what's interesting about the material is just how broad it is. It goes from, the absolute fundamentals right up to quite advanced hybrid setups.
And the references to specific Azure guides show you're looking at the practical side of managing these integrated systems.
Mm-hmm.
Okay, let's unpack this, starting with a big one. Virtualization with Hyper-V.
Mm-hmm.
I mean, for anyone who remembers server sprawl, running multiple virtual servers on one box is, well, it's a game changer.
Oh, definitely.
What makes Hyper-V in Server 2022 stand out, especially for hybrid?
Well, beyond just consolidating servers, Server 2022 Hyper-V has features that really help with management and the user experience. Remote FX, for instance, though, needs specific hardware aims to give a better remote desktop feel, especially for graphical apps.
Kind of bridging that gap between local and remote work.
Exactly. Then there's scripting with WMI, Windows Management Instrumentation. That's huge for automation, especially when you're managing potentially lots of VMs across on-prem and cloud.
Right, automation is key.
And shared virtual hard disks are important for clustering VMs. That boosts availability for services that might be needed by both local and cloud users.
Okay, so when you're actually spinning up a new VM in Hyper-V, what are the absolute must-do steps?
The initial setup is foundational, right? You got to name it logically, decide where the config files live.
Sensible defaults.
Usually, but good to check.
Yeah.
Then choosing the generation matters. Generation 2 for most modern OCs gives you things like UEFI firmware, faster boot, and newer features.
Got it. Gen 2 mostly.
Then memory allocation. You need enough for the VM, obviously, but don't starve the host.
It's a balancing act.
Totally. And finally, connecting it to a virtual network adapter. That's essential for it to talk to anything, whether it's your local network or reaching out to Azure.
Makes sense. Now, virtual hard disks,
Hmm?
they probably need some ongoing care, right? What kind of actions are we talking about?
Absolutely. You might need to compact a dynamically expanding disk to get unused space back,
Housekeeping.
pretty much, or convert between types, maybe dynamic to fixed for performance reasons. Expand is obvious when you need more space.
Easy enough.
Merge is for differencing disks, rolling changes back to the parent. And reconnect if a differencing disk loses its link to the base. Can happen.
Okay. And during setup, you mentioned integration services. What's their main job?
Think of them as like the drivers that help the VM talk properly to the physical host. They provide really essential stuff.
Like what?
Time synchronization keeps all VM clocks accurate, super important.
Crucial, yeah.
Enhanced session mode for a better remote connection experience. And guest services allow some controlled data exchange between host and guest. Useful for management.
Gotcha. Now, one feature that sounds interesting is automatic virtual machine activation, AVMA. How did that simplify licensing, especially in hybrid?
AVMA is a real efficiency booster, yeah, especially with lots of VMs. Basically, if your Hyper-V host is properly licensed with, say, Data Center Edition,
Okay.
the VMs running on it can activate automatically. No need for individual product keys for each VM.
Seriously, that saves a ton of hassle.
It really does. The VM just checks against the host's license. Your guide even lists the specific AVMA keys for data center and standard, which is handy if you're activating VMs that are maybe offline or remote.
But the host itself has to be activated properly first.
Oh, absolutely. That's the prerequisite. But yeah, AVMA is great for large deployments or places without easy internet access for activation.
All right, let's pivot. Foundational pillar time, .networking. Starting with TCP/IP.
Right.
Why is it always called the linchpin?
Well, TCP/IP, Transmission Control Protocol, Internet Protocol, it's just the fundamental language devices used to talk on a Windows network, or really any network, including the Internet.
It's common tongue.
Pretty much. IP handles the addressing and routing, getting data packets to the right place. TCP makes sure the delivery is reliable, ordered, and error-checked.
So IP finds the house, TCP makes sure the mail gets delivered correctly.
This is a decent analogy, yeah. Understanding TCP for reliability, maybe UDP for speed in some cases. It helps. Without TCP/IP set up right, your on-prem and Azure stuff just won't communicate, period.
Okay. And then there's DNS domain name system. The guide really stresses its importance, especially with Azure. Why is it so vital?
DNS is basically the phone book for your network. It translates human-friendly names like myapp.com into the IP addresses computers actually use.
The numbers.
Right. And that's absolutely critical for Azure because your cloud services have IP addresses too. When someone on-prem tries to hit a web app in Azure, DNS finds its IP address. Good DNS config means seamless name resolution across the whole hybrid setup.
So let's clarify that DNS hierarchy. What exactly is a fully qualified domain name, an FQDN?
Think of DNS like an upside-down tree, root at the top, then top-level domains like .com, .org, then second level like Microsoft.
Okay.
An FQDN is the full, unique name for a specific computer on that tree. It includes all the levels back to the root, like webserver.sales.contoso.com. That trailing dot you sometimes see, technically part of it, signifies the root.
Ah, right, the dot. Now, the guide lists a bunch of DNS record types, SOA, NS, APTR, CNAME, MX, SRV. That's quite a list.
Yeah.
Can you give us the quick rundown on their main role?
Sure. Each one is a specific job. SOA start of authority has admin info for the zone. NS name server points to the servers responsible for a domain or subdomain.
Okay.
A record maps a host name to an IPv4 address. Fundamental. PTR pointer does the reverse. IP back to host name. Useful for troubleshooting.
Reverse lookups, got it.
CNAME canonical name creates aliases. One name points to another. MX mail exchanger says where email for the domain should go.
True email servers.
Yep. And SRV service records are super important for finding specific services. Like they help clients find domain controllers for Active Directory, telling them the server, port, and protocol. All these records make sure things are discoverable in your hybrid network.
Makes sense. Now, DNS zones. Primary, secondary, Active Directory integrated. What's the difference, and why is AD integration often preferred, especially hybrid?
Okay, so a primary zone holds the main writable copy of the DNS records. A secondary zone holds a read-only copy, gets updates from the primary via zone transfers.
Okay, master and copy.
Right. Active Directory integrated zones are different. They store the DNS data inside the Active Directory database itself.
Ah, clever.
Yeah, it has big advantages. The DNS data gets replicated automatically and securely, along with other AD data, to all domain controllers running DNS. Great for fault tolerance.
No data redundancy.
And it allows secure dynamic updates. Only authenticated domain machines can register or update their own DNS records. Much more secure, less manual work.
That sounds like a big win. The guide also mentions zone transfers and refresh, retry, expire times. What's the practical importance there?
So zone transfers are how secondary zones get updates from the primary. The refresh interval is how often the secondary checks for changes.
How often it pulls.
Exactly. If a transfer fails, retries how long it waits before trying again. And expire is the safety net. If the secondary can't reach the primary for that long, it stops giving out its potentially old data.
Prevents serving stale info.
Right. Tuning these balances how quickly changes spread versus network traffic and resilience if the primary is down for a bit.
Okay. And briefly, round-robin DNS for load balancing. Where might you see that, and what are its limits?
Round-robin is super basic load distribution. If one host name, say www.conso.com, has multiple A records pointing to different web server IPs.
Like 3 different servers.
Yeah. The DNS server just hands out those IPs one after the other in a cycle. Client 1 gets server A, client 2 gets B, client 3 gets C, client 4 gets A again.
Spreads the load a bit.
A tiny bit.
Yeah.
But it's dumb. It doesn't know if server B is overloaded or even offline. It'll still send clients there. So it's basic distribution, not really intelligent load balancing with health checks.
Got it. Simple, but limited. Okay, let's shift to DHCP Dynamic Host Configuration Protocol. Automating IP addresses. Big benefit in growing or hybrid networks.
Huge benefit. The HCP automates assigning IP addresses, subnet masks, gateways, DNS servers, all that stuff you'd otherwise have to type in manually on every single device.
Which is tedious and error-prone.
Exactly. Saves loads of admin time, prevents IP conflicts. In a hybrid setup, it ensures consistent network config for on-prem devices, maybe even some cloud-integrated things.
The guide mentions the lease renewal process, specifically T1. What's happening there?
Right. A DHCP lease isn't permanent. T1 is the client's first try at renewing its lease. It happens about halfway through the lease duration.
Okay.
The client sends a direct message, a unicast, just to the DHCP server that gave it the lease, asking, can I keep this IP longer?
Polite request.
Yeah. If the server says yes, the lease is extended. If it doesn't respond, the client waits and eventually hits T2, where it broadcasts the request to any available DHCP server.
Okay, T1 is the polite ask. P2 is shouting for help.
Kinda, yeah.
So when setting up a DHCP scope, what are the absolute essentials you need to define?
A scope is the pool of addresses the server can hand out, so you need the start and end IP address for the range.
The main pool.
Yep. Then, crucially, any exclusions addresses within that range you don't want handed out automatically, maybe for servers, printers with static IPs.
Reserve those manually.
Right. And reservations let you permanently tie a specific IP to a specific device's MSC address. Ensures that printer always gets the same IP.
Handy.
And finally, options. That's where you define the default gateway, DNS servers, maybe RENS servers if you still use them, domain name, all the extra config clients need.
Got it. Cool, exclusions, reservations, options. What about superscopes? Handling multiple subnets on one physical network. When would you use that?
Superscopes are useful when your physical network layout doesn't quite match your IP subnet plan.
Yeah.
Maybe you're migrating between subnets.
Like moving from a 192.168.1.x to a 10.0.0.x.
Exactly. But you haven't physically separated the networks yet. Or maybe you just ran out of IPs in your original subnet and need to add another logical subnet onto the same physical wire temporarily. A superscope lets one DHCP server manage leases for both subnets on that segment.
Okay, kind of a workaround for network growing pains.
Sometimes, yeah.
Sure.
How does DHCP DNS integration help? Automating DNS updates sounds useful. It's incredibly useful. When the DHCP server gives out an IP, it can automatically talk to the DNS server and create or update the A record, name to IP, and the PTR record, IP to name, for that client.
So no more manually adding DNS entries when a machine gets a new IP.
Precisely. Saves time, reduces errors, keeps DNS accurate almost in real time. Big help.
Definitely. Lastly, on networking for now, DHCP failover and IPM, IP address management. What benefits do they bring to a robust hybrid setup?
DHCP failover gives you high availability for DHCP itself, which is critical, right? If DHCP is down, clients can't get IPs.
Network grinds to a halt.
Pretty much. Failover lets you set up two DHCP servers that share lease info. If one fails, the other takes over seamlessly. You can do load balancing mode or hot standby.
So redundancy for critical service.
Exactly. And IPM IP address management is a feature in Windows Server that gives you a central console to manage and monitor your entire IP address space, plus your DHCP and DNS servers.
One dashboard to rule them all.
Sort of. Especially useful in complex hybrid networks. Track IP usage, check server health, enforce policies, all from one spot. And yeah, it integrates really well if you're mostly a Microsoft shop.
Right, makes sense. Okay, let's move into hybrid identity. Active Directory and Azure AD. We know AD is the bedrock on-prem. What are its core jobs?
Active Directory, or ADDS, is basically your central directory on premises. It manages users, computers, groups, security. It handles authentication, proving who you are.
Logging in.
Right. And authorization, figuring out what you're allowed to do or access. Plus, central security policy management. A single AD is a domain, and you can group domains into forests for bigger organizations.
The guide mentions improvements like privileged access management, PAM, in newer AD versions. How does PAM boost security, especially thinking hybrid?
PAM tackles the risk of having accounts with permanent admin rights just sitting there waiting to be compromised.
Like domain admins.
Exactly. PAM creates a separate, more secure environment for admin tasks. Admins request temporary access to privileged groups, and that access expires automatically.
Just-in-time access.
Precisely. It shrinks the window for attackers to exploit stolen admin credentials. Huge security improvement for on-prem and anything connected, like hybrid resources.
Makes sense. Now, what's involved in promoting a standard Server 2022 box to a domain controller?
Yeah.
And why are DNS SRV records so vital here?
Promoting involves installing the ADDS role, then running the configuration wizard. It sets up the server as a directory authority. DNS SRV records, service location records, are absolutely critical. They're like signposts in DNS telling clients and other servers where to find essential AD services.
Like the login service.
Exactly, like Kerberos for authentication, LDAP for directory lookups, the global catalog. Without the right SRV records published in DNS, clients can't find the domain controllers, can't join the domain, can't log in. Game over.
So DNS has to be working perfectly before you promote.
Absolutely. AD relies heavily on DNS.
Once you have a DC, how do you actually join client machines to the domain?
First, make sure the client PC is pointing to a DNS server that knows about your domain, usually one of your DCs.
Right, so it can find those SRV records.
Yep. Then you go into the client system settings, choose to join a domain, type in the domain name, and provide credentials for a domain account that has permission to add computers.
Like a domain admin or someone delegated that, right?
Exactly. The client then talks to a DC, authenticates, and its computer account gets created in AD.
Okay. Now, organizational units OUs. The guide calls them key for structuring AD and delegating tasks. How do they work?
OUs are basically folders inside your AD domain. You use them to organize objects, users, computers, groups, logically, maybe by department or location. Mirrors your company structure often.
Like a sales OU, a marketing OU.
Perfect example. You create and manage them with the Active Directory Users and Computers tool, ADUC. But their real power is delegation.
Ah, giving out specific permissions.
Right. You can grant someone, say, the help desk team for sales, the right to reset passwords only for users in the sales OU without making them domain admins.
Least privilege in action.
Exactly. ADUC has a wizard to help delegate specific tasks, even custom ones you define. Very granular control.
User and group management are fundamental AD tasks. Any best practices highlighted, like user templates or group types?
User templates are a great tip. Saves time, ensures consistency. You create a template account with common settings already filled in, department, office, maybe standard group memberships.
Like a baseline new user?
Precisely. Then when you hire someone new, you just copy the template and fill in the unique bits. Much faster, fewer errors.
Smart. What about groups?
Key thing is the difference between security groups and distribution groups. Security groups are for granting permissions to resources, files, folders, applications. Distribution groups are just for email lists.
Use the right tool for the job.
Exactly. Using a distribution group to grant permissions won't work. Understanding that is crucial. You can also nest groups for more structure.
Okay. What about resetting a user's password? Common task. Any gotchas, especially regarding the computer's domain connection.
Resetting is straightforward in ADUC. You reset it, maybe check the box for user must change password at next login.
Standard procedure.
Yeah. But sometimes, if the computer itself has lost its secure connection to the domain, its trust relationship is broken, which can happen for various reasons.
Like if it's been offline too long.
That's one cause. Just resetting the user password might not be enough for them to log in properly or access resources. You might need to remove the computer from the domain and rejoin it, or try repairing the secure channel with PowerShell, like using test computer secure channel def repair.
Ah, okay. So sometimes it's more than just the user password.
It can be, yeah.
All right, let's shift to the cloud side. Azure Active Directory, or Azure AD, Microsoft's cloud identity service. How does it fit into the hybrid picture?
Azure AD extends your identity management into the cloud. It handles cloud user group management, single sign-on, SSO, to cloud apps and potentially on-prem apps, device management for cloud-connected devices, and powerful security like multi-factor authentication, MFA, and conditional access.
So it works with on-prem AD.
Often, yes. In hybrid, they work together to give you a unified identity across both worlds.
The guide mentions external identities. Sounds useful for collaboration. How does that work?
External identities in Azure AD lets you securely work with people outside your company, partners, vendors, contractors.
Guest users.
Exactly. You can invite them to access specific apps or resources in your Azure AD. They can log in using their own existing accounts, like their Work Azure AD, a Microsoft account, or even Google or Facebook in some setups.
So you don't have to create and manage accounts for them.
It simplifies collaboration hugely, but you still control what they can access using policies.
Neat. What about Azure AD roles, like global admin or help desk admin? How do they help manage hybrid?
Azure AD roles follow that same principle of least privilege we talked about with OUs. You assign roles with specific permissions needed for a job, rather than making everyone a global admin.
Which has, like, keys to the kingdom.
Pretty much. A user admin can manage users, a help desk admin can reset passwords for regular users, etc. Using these roles limits the potential damage if an admin account is compromised. Very important for security.
Makes sense. Conditional access policies are also highlighted for security. How do they work in a hybrid world?
Conditional access is really powerful. It lets you set access rules based on context, who is logging in, what device they're using, where they are, what app they're trying to access, even the assessed risk of the sign-in.
So you can set rules like, if logging in from outside the corporate network, require MFA.
Exactly. Or block access from non-compliant devices, whether those devices are managed by Intune in the cloud or Configuration Manager on-prem. It lets you apply zero trust principles across the board.
Very granular control.
Yeah.
Now, connecting on-prem AD and Azure AD, that's Azure AD Connect, right? What are the main ways it syncs or federates identities?
Yep, Azure AD Connect is the tool for that integration. It offers a few main methods. Password hash synchronization, PHS, is common. Syncs a secure hash of the on-prem password to Azure AD. Users have the same password everywhere.
Simple and effective.
Often, yes. Pass-through authentication, PTA, is another option. Azure AD actually passes the login attempt back to an agent on your on-prem network to validate against your local AD in real time.
So the password never lives in the cloud.
Correct. And federation, usually with ADFS, Active Directory Federation Services, is the most complex but flexible. It relies entirely on your on-prem ADFS infrastructure to handle the authentication. The choice depends on your needs, security posture, existing setup.
Okay, PHS, PTA, federation. Got it.
Yeah.
Lastly, for this section, hybrid networking. Azure VNets, site-to-site VPNs, ExpressRoute. How do they create that seamless connection?
Azure Virtual Networks, or VNets, are your private network spaces in Azure. To connect your on-prem network securely to your VNet, you typically use a site-to-site VPN.
An encrypted tunnel over the internet.
Exactly. Makes your on-prem and Azure resources feel like they're on the same network. For bigger, needs more bandwidth, lower latency, higher reliability, there's ExpressRoute.
That's the dedicated private connection.
Right. Bypasses the public internet entirely, connects directly into Microsoft's network. More expensive, but essential for some scenarios. These network links are fundamental. They're the pipes that make hybrid work.
Absolutely. Okay, let's switch gears to storage management in this hybrid world. The guide starts with file systems, NTFS and ReFS, strengths and weaknesses.
Okay, NTFS NT file system, that's been the Windows standard forever. It's reliable, compatible, full-featured, does the job for most things, including boot drives.
The old reliable?
Pretty much. ReFS Resilient File System is newer. Its big focus is data integrity and availability. It has features to actively detect and even fix data corruption on the fly.
Sounds good for important data.
Definitely. It's often preferred for things like large archives or storing virtual machine files where bit rot is a concern. But as the guide notes, you usually can't boot from ReFS, and compatibility might be less broad than NTFS. ReFS also has some performance tricks like block cloning, good for virtualization.
So choose based on the workload. What about basic versus dynamic disks?
Yeah.
And those dynamic disk features spanned, striped, mirrored, RAID 5.
Basic disks are the traditional partition style. Simple, limited partitions. Dynamic disks are more flexible. You can create volumes that span across multiple physical disks.
Making one big volume out of several small disks.
Yep, that's a span volume. No fault tolerance, though. Striped volumes, RAID 0, write data across multiple disks simultaneously for speed. Again, no redundancy, one disk fails, all data gone.
Fast but risky.
Exactly. Mirrored volumes, RAID 1, write identical data to two disks. If one fails, the other keeps going. Good redundancy.
Safe, but uses double the disk space.
Right. And RAID 5 stripes data and parity info across 3 or more disks. It can survive one disk failure. Good balance. But as noted, you can't put OS or boot files on dynamic RAID 5. Dynamic disks also let you resize volumes more easily, often without rebooting.
Flexibility is the key there. Now, storage spaces sounds powerful for adaptable storage. How do pools and tiers work?
Storage spaces lets you group physical disks, even different sizes and types, into a storage pool. Think of it as a big bucket of raw capacity.
Okay, just raw space.
That's right. Then, from that pool, you carve out virtual disks called storage spaces. What's cool is tiered storage. You can put fast SSDs and slower, larger HDDs in the same pool.
And storage spaces manages them.
Yeah. It automatically moves frequently accessed data, hot data, to the fast SSD tier and less used cold data to the cheaper HDD tier. Gives you SSD-like performance for active data without paying for all SSD storage.
Smart tiering. Nice. The guide briefly mentions ISCSI and ISNS servers. What's ISCSI and what does ISNS do?
ISCSI, Internet SCSI, basically lets you run storage traffic over your regular Ethernet network. It packages SCSI commands into IP packets. Makes SANs, storage area networks, more accessible without needing dedicated fiber channel hardware.
Storage over Ethernet.
Essentially. An ISNS server, Internet Storage Name Service, acts like a directory for your ISCSI stuff. It helps servers, initiators, find the storage devices targets automatically without you manually configuring IPs and complicated names for every connection. Simplifies discovery.
Like DNS for ISCSI.
Good analogy, yeah. What about thin provisioning and trim? How do they help optimize virtual storage? Thin provisioning lets you present more storage to a VM than you've actually allocated physically right now. The physical space is only used as the VM writes data. Better utilization up front.
Allocate less, pretend it's more.
Kind of, yeah. Save space initially. Trim is a command the OS inside the VM sends to the underlying storage, especially SSDs. It says, hey, these blocks aren't needed anymore.
Like emptying the recycle bin properly.
Exactly. It lets the SSD reclaim that space efficiently, which improves performance and longevity. Both help make virtual storage more efficient.
Okay. File and folder security. NTFS permissions versus shared permissions. How do they interact? Which one wins?
Right, 2 layers.
Oh,
NTFS permissions are set directly on the files folders on the disk. They apply whether you access locally or over the network.
the core permissions?
Yep. Shared permissions are only set on the shared folder itself and only apply when accessed via that share over the network.
Okay, only for network access.
And when someone accesses a file through a share, both sets of permissions are checked. This system applies the most restrictive combination.
Ah, the stricter one wins.
Always. If NTFS says full control but the share says read-only, you only get read-only through that share.
Got it. Important distinction. Disk quotas and data deduplication managing space.
Disk quotas let you limit how much space individual users can consume on a volume, stops one person hogging all the space on a file share.
Keeps things fair.
Right. Data deduplication is clever. It finds identical chunks of data across all files on a volume and only stores one copy, using pointers for the duplicates.
Like finding duplicate paragraphs in different Word docs.
Exactly, but at the block level. Can save huge amounts of space, especially on file servers or VM libraries where you have lots of similar OS files. Just need to make sure your backup software understands dedupe.
Good point. Lastly, for storage. File Server Resource Manager, FSRM, and BitLocker. Management and security.
FSRM is a toolkit for managing file servers. You can set quotas, more advanced than basic quotas, implement file screens to block certain file types, like MP3s on a work share, run storage reports, and even automatically classify data based on content.
More control and insight.
Definitely. And BitLocker is Windows' built-in full disk encryption. BitLocker Drive encryption encrypts the OS drive and fixed data drives. BitLocker To Go encrypts removable drives like USB sticks, protects data at rest if a laptop or drive is lost or stolen.
Essential data protection.
Absolutely.
Okay, let's shift to security and disaster recovery specifically. When is Defender Firewall the first line of defense? How do you configure rules, and what are some key ports?
The firewall controls traffic in and out. You create rules to allow or block traffic based on port number, protocol, TCP/UDP, maybe the application.
Allowing only what's needed.
Right. Common ports you'll manage are 80 for HTTP, 443 for HTTPS, secure web, maybe 21 for FTP, 25 for email, SMTP, 53 for DNS. DHCP uses 67 and 68. You create inbound rules for services on your server people need to reach, and outbound rules to control what your server can reach out to. Careful config is vital.
Got it. Microsoft Defender for Endpoint is mentioned for threat protection and response. How does it work, and how does Intune integration help?
Defender for Endpoint is a bigger platform. It collects tons of data from endpoints' process activity, network connections, logins, and uses analytics and machine learning to detect advanced threats that basic antivirus might miss.
EDR endpoint detection and response.
Exactly. It helps you prevent, detect, investigate, and respond. The integration with Intune, part of Endpoint Manager, lets you push Defender policies and get visibility across devices managed by Intune, like mobile devices or co-managed PCs. The Security Ops dashboard gives you that central view of risk levels and alerts.
Okay, broader protection. What about Defender Application Guard? Isolating untrusted stuff.
Application Guard creates a mini isolated virtual machine, a sandbox, just to open potentially risky things like websites from unknown links or suspicious Office documents.
Like opening a dodgy email attachment.
Perfect use case. It opens in that secure container. If there's malware, it's trapped inside and can't touch your main OS or data. When you close the guard window, the sandbox is wiped clean.
Neat way to contain threats.
Very effective for web browsing and document security.
Now, group policy. Hugely powerful. What are GPOs, and how does inheritance work?
Group policy lets you centrally configure settings for users and computers in AD. The settings are bundled into group policy objects, or GPOs.
Collections of settings.
Right. You link these GPOs to AD sites, domains, or most commonly OUS. Inheritance means settings applied at a higher level, like the domain, automatically flow down to containers underneath, like OUS, unless blocked.
So you set a baseline at the top.
Yeah, simplifies things, but you can block inheritance or enforce a policy so it overrides lower ones. If settings conflict, generally the one applied closest to the user computer wins, the last one applied wins rule.
Okay, layers of control. How do you delegate control over group policy itself?
You can do that in the Group Policy Management Console, KPMC. You can give specific users or groups the right to manage GPOs linked to a specific ORU, for example.
Like letting the HR IT person manage HR-related policies.
Exactly. Again, least privilege. Delegate control without making them domain admins.
The guide mentions using scripts via group policy, startup shutdown, log-in log-off scripts.
Yep, group policy can run scripts, PowerShell, VB script, batch files at key times. Startup scripts run when the computer boots, before login. Shutdown scripts run during shutdown.
Computer-level tasks.
Right. Logon scripts run when a user logs in. Log-off scripts run when they log out. Great for mapping drives, setting registry keys, deploying small bits of software. Lots of automation potential.
Powerful automation tool. Okay, disaster recovery.
Right.
Azure Backup for cloud backups. How does it handle on-prem versus Azure VMs?
Azure Backup is Microsoft's cloud backup service. For on-prem servers or workstations, you install the Mars Agent Microsoft Azure Recovery Services agent. It backs up files, folders, system state directly to an Azure Recovery Services vault.
Agent-based for on-prem.
Mostly, yes. For Azure VMs, the preferred way is the Azure Backup extension. It integrates directly with the VM, allows for application-consistent backups of the whole VM. You can use the Mars agent inside an Azure VM just for file folder backup if needed.
Extension for Azure VMs. Got it. What about Azure Site Recovery? ASR for Docker. What's involved in setting up replication or recovery plans?
ASR is the full DR orchestration service. It replicates entire machines, Hyper-V, VMware, physical servers on-prem, or even Azure VMs to a secondary location, usually another Azure region.
Replication for failover.
Exactly. Setup involves preparing the target environment, like networking in Azure, configuring replication for the VMs, how often, where to store replicas, and then building recovery plans.
The step-by-step failover instructions.
Precisely. They define the order VMs should start in during a disaster, any network changes needed, like IP readdressing and other scripts or manual actions. Testing these plans regularly is absolutely crucial.
Test. Makes sense. Moving into hybrid management and automation, Microsoft Endpoint Manager, what does it manage?
Endpoint Manager is the umbrella brand for Microsoft's device and app management tools, bridging cloud and on-prem. It includes Intune for cloud-based MDMMA.
Mobile devices, cloud-first PCs.
Right. And Configuration Manager, Config-SER, formerly SECM, for traditional, more powerful on-prem management of servers and desktops. Co-management lets you use both together on Windows devices, gradually shifting workloads to the cloud. It uses Azure AD for identity across the board.
Unified platform idea.
That's the goal. Windows PowerShell is obviously key for automation. Any particular CMDlets jump out for hybrid management? Oh, tons. For Hyper-V, get VM, new VM, start VM. For DNS, get DIN server zone, add DIN server resource recorder. For DHCP, get DHCP server for scope, add DHCP server for reservation.
Standard admin tasks.
Yeah. For IPAM, CMDlets start with IPAM. For Active Directory, the whole AD module, get AD user, new AD group, set AD computer. For failover clustering, get cluster, move cluster group. Knowing PowerShell is essential for efficient hybrid admin.
Definitely a force multiplier. What about Windows Admin Center, the browser-based tool? How does it help with hybrid?
Windows Admin Center, WAC, is a modern web-based GUI for managing servers, clusters, HCI. It's great for day-to-day tasks. Its hybrid strength is integrating Azure management directly. You can onboard servers to Azure Monitor, configure Azure Backup, set up Azure Site Recovery replication, manage Azure VMs, connect to Azure VNets, all from the WAC interface. Makes hybrid tasks feel more integrated.
Single pane of glass attempt.
Getting closer, yeah. Especially for core server and Azure hybrid tasks. Finally, Azure Monitor for data collection and analysis. What can it watch? Azure Monitor collects telemetry from pretty much everywhere. Azure resources, on-prem servers, via an agent, applications. It collects metrics, performance counters like CPU, memory, logs, event logs, application logs, syslogs, and tracing data for apps.
Centralized monitoring.
Exactly. It gives you that end-to-end visibility across your hybrid environment. You can analyze performance, set up alerts for problems, troubleshoot issues, build dashboards, essential for understanding the health of everything.
Very important. Okay, let's wrap up with high availability HA and DR tech. Network load balancing, NLB. How does it help HA?
NLB provides availability and scalability mainly for stateless network services, like web servers. It spreads incoming requests across multiple servers in an NLB cluster.
Distributing the traffic.
Right. If one server fails, the others pick up the slack. It operates at the network layer, distributing based on IP and port. Simple, effective for specific workloads.
What about failover clustering? More comprehensive HA. What about shared storage?
Failover clustering provides HA for stateful applications, things like SQL Server, file shares, Hyper-V VMs. It groups servers, nodes together. If one node fails, its workload, the clustered role, automatically fails over and starts on another node.
One takes over for the other.
Exactly. Traditionally, this required shared storage accessible by all nodes, Fiber Channel SAN, ISCSI, SAS. That's the key difference from NLB. Failover clustering provides redundancy with failover. NLB provides load distribution, though newer tech like Storage Spaces Direct changes the shared storage requirements somewhat.
Okay, different purposes. Live migration in Hyper-V. Moving running VMs without downtime. When is that useful?
Incredibly useful, primarily for planned maintenance. Need to patch a Hyper-V host. Live, migrate the VMs off it, patch the host, then migrate them back. Zero downtime for the VM users.
Seamless maintenance.
Yep. Also good for load balancing, manually moving VMs around to spread resource usage evenly across hosts. The key is no interruption to the service running inside the VM.
Very cool tech. Hyper-V replica for Dogger. How does that help?
Hyper-V Replica is built-in VM replication. It asynchronously copies a running VM from a primary Hyper-V server to a replica server, maybe at a different site or even in Azure.
Creating a warm standby VM.
Essentially, yes. If the primary site goes down, you can manually fail over and start the replica VM at the secondary site. Basic, effective DR for VMs. You can figure how often it replicates.
Another layer of protection. And finally, Azure Site Recovery again. Crucial configurations for hybrid DR.
We touched on it, but yeah, ASR is often the core of a hybrid DR strategy. Key configs include setting up the Azure target network properly, defining replication policies, frequency retention, ensuring adequate bandwidth for replication, and most importantly, creating and regularly testing those recovery plans that orchestrate the failover.
The testing is key.
Absolutely. A DR plan you haven't tested is just a document. You need to know it works.
Well, that was definitely a deep dive. We covered a lot of ground virtualization, networking, identity, storage, security, DR, all looking through that Windows Server 2022 hybrid lens.
Absolutely. And it really highlights how interconnected everything is in these modern environments. You can't really manage one piece in isolation anymore.
For sure. And like we said, this was about pulling out the essential insights from your guide to give a solid foundation. We definitely encourage everyone to go back to the source material for the finer details on areas that caught their interest.
Definitely. So for our final thought today, considering this powerful integration between Windows Server 2022 on-prem and all these Azure services we've discussed, how do you think this fundamentally changes IT infrastructure management and resilience? Based on our chat, what do you see as the biggest opportunities and maybe the biggest challenges when organizations really embrace these hybrid setups?